welcome to lecture 91. So, we have discussed last time about the interplanetary transfer. So, in that context, we looked into how the Hohmann transfer will take from one planet to the another planet, and thereafter we also looked into the we have to get out of the influence of the sphere of Earth, out of the influence sphere of influence, what we call SOI, the sphere of influence of Earth. We need to get out of that. So, getting out of that, it requires certain velocity to be given at the perigee. Okay. So, that velocity we are imparting here. Okay, so, that velocity will be imparted here at the perigee position, the extra velocity. So, in that context we have I have made this figure, kept it ready for the reference purpose. So, see here on the left hand side, leftmost side, this gamma is shown, which is the horn of the Aries, okay, and this is the direction for the vernal equinox. The same thing is also shown here, the line coming out from the center of the earth. So, the figure remains same as we have drawn in the last class. So, the green line here, this green line, what it is shown here, the as a circle. So, this represents your earth. So, let us say that the earth is just represented by this green ball at this point. Okay. So, I will even remove this this particular part here, so that our representation is much more clear. Okay. So, green ball shown here, this is the earth, and the left hand side here in this place, this is your sun as written here. R e is the radius vector of the earth. So, here this is the radius vector shown till this point, till the center of the earth. Okay. So, radius vector goes all the way from this point to this point. Similarly, a small r, just as r, is the radius vector of the vehicle. So, vehicle is located here. This angle is L e, which is the longitude of R e. So, this is being measured from the vernal equinox. Okay. Similarly, if we look here in this place, I have written here L e. So, and this gamma is also shown here in this place, the angle measured from this place as shown by this L e, okay, as you can see here. So, this angle is the locates the this unit vector R e, or the line L e which is drawn. So, it locates this with respect to the vernal equinox. So, this L e and this L e both are same. So, that means this and this, they are parallel, both are toward the vernal equinox. Okay. Beside this, I have shown here the L h. L h is the perigee position, line of periapsis line I have written. So, the last time as I have shown there, in the hyperbola, if we give impulse. So, this is the velocity at the perigee. If this is the impulse given here in this point, V p minus B c, where c is the velocity in the. So, V p already I have written here, velocity of the satellite in the parking orbit at the perigee of the hyperbola. So, this line is your parking orbit. So, in the parking orbit at this point, where the periapsis is located. So, here we give an impulse. Okay. So, the parking orbit and hyperbola perigee, they are touching each other, these are touching. So, impulse is given at this point. Okay. So, that makes the velocity of the satellite V p, and thereafter it goes here and reaches the sphere of influence, where I have shown this as the vehicle. Okay. So, all the angles we have to describe here, and then this green line, the light green line, this one, this is the light green line. So, this is the trajectory of hyperbola, this is the trajectory of vehicle. So, satellite is coming out of the sphere of influence here in this point, and this dark line, these are the asymptotes of the hyperbola. Okay, and psi is as indicated, this is measured with respect to, as we have done in the conic section. So, this is the angle psi here of the asymptotes measured with the periapsis line. Okay. Now, this angle, the angle shown here, this one where I am drawing, and this line it goes here, this is LE minus LH, because the angle for the LE you are measuring from, LE is being measured all the way from line of periapsis. I will have to draw one more line, I will draw a light line for this. So, you are measuring LE from this place to this place. So, this is your indicating LE. This is LE. So, immediately you can see that this angle will be LE minus LH, and then therefore, this being the external angle, this one, this becomes LE minus LH plus psi. The psi plus this angle added together, this becomes here LE minus LH plus psi. So, the opposite angle here in this place, as shown by this particular segment, the angle here, this is LE minus we have shown this part, I am removing this line. I will show this part here as LE minus LH, and remove this from this place for clarity purpose. Okay. So, this angle which is the vertex angle, then this becomes LE minus LH plus psi. If, as it is written here, this is the true anomaly of the vehicle as measured from the periapsis. So, F is shown here in the pink. Okay. You see here, this is the pink line, it is shown here in this place. Okay. So, this is your F. So, this is F. Then phi is the angle between the RE vector here and the VE vector, as shown by orange line, orange or red line, it is a red line. Okay. As shown by the red line here, this angle, this is your phi. Okay. All the angles need to be written carefully. So, if the pink, by pink we have shown the F angle. So, you can see that this is your phi minus F angle as shown here. Okay. So, this angle is phi minus F, I am showing again by red line. Okay. And this angle is LE minus H, and therefore, this is also this angle, this will be LE minus H, because it is a vertex angle, and therefore, the alpha angle which is shown here, alpha will be equal to LE minus LH plus phi minus F. So, alpha equal to phi minus F plus LE minus LH. angle between vehicle V, angle between V, angle between V and V infinity, we write this as gamma, and angle between V infinity and V r we write as beta. So, these are the nomenclature here. Phi minus f. You are carefully representing all the angles. Okay. So, based on this, now we can start writing the equations for the various angles and the relations. Figure looks very complicated, but it is not very complicated. It is just because of rewriting and drawing various line, it is appearing little complex. Okay. Okay, now we start working with the angles. So, already last time we have derived this relation psi equal to tan inverse V p by V c times square minus 2 to the power 1 by 2. This is the relation last time we have got. Also, we can observe from the previous figure that this r vector, this vector will be nothing but r will be r e plus rho, where rho is the vector till the vehicle, okay, as shown here. This is the rho vector, this is your rho vector. So, r equal to r e plus rho, and therefore, the rho can be written as and rho square equal to r e square plus r square so r e square plus r square minus 2 r e cos theta. Here theta is the angle between, this is the angle between r and r e, okay. And therefore, cos theta becomes rho square cos theta equal to r square plus r e square minus rho square divided by 2 times r e. And if you look here in this cos theta, we have to determine also this cos theta. So, then r we know, r is known from r e and rho. Rho is known to us because this we get from estimation orbit determination problem, and the r earth which is shown here, this is known from JPL, Jet Propulsion Laboratory. This is NASA JPL developmental ephemeris 405. So, it is a program is there. So, from there you get it. The program is written in Fortran. Obviously, it is not so easy to understand that also. You need certain experience, thereafter you can work on all these things. Okay. So, therefore, the cos theta can be determined. Okay. Thereafter, we have also Re plus rho equal to R, and this we can write as R square equal to Re square plus rho a square plus 2 Re dot rho, and so R square becomes 2 Re rho times cos. Okay. The angle between Re and rho, angle between Re and rho is, now we see here, I will draw the figure here in this place. This is your rho vector and the Re vector is going here in this direction, and so this is Re cap. Okay, and Re is coming from the sun till the earth. The earth is located here. This angle you have taken as alpha. Okay, and therefore, this angle is phi minus alpha. So, the angle between the Re and the rho vector is phi minus alpha, and this gives you Re square rho square plus 2 Re rho times, here this will be minus, and therefore, from this place R by Re square rho by Re square minus 2 cos alpha. So, therefore, from this place we can get the angle cos alpha, which will be equal to 1 plus rho by Re square minus whole square divided by 2 rho by Re. So, cos theta is known, alpha is known. So, all these things, because the rho and Re, all these things are known, and therefore, this angles become known. Then we go to the vehicle. Okay. So, it is shown that V infinity is in this direction and V earth is shown like this. V infinity is shown like this, and then the V earth, we show it by proper color. This is the V earth, and VR resultant is shown in black. So, resultant is VR. This angle we have written as beta, and the angle from here to here, this we write as gamma. Moreover, angle with the horizontal, this angle as shown here, this is LE minus LH plus psi. This angle is LE minus LH plus psi. So, we will utilize all this information for solving the problem here. So, V r, then this becomes V infinity a square plus V a square, okay, plus 2 times V infinity times V cos gamma. This is the angle between, this is your V infinity. So, V r equal to V e plus V infinity. So, if we take the dot product V r dot V r, so this gives you V e square plus V infinity a square plus 2 V times V infinity, this is dot. The angle between these two is gamma, therefore, here it comes as cos gamma, and here this is a square. Okay. Thereafter, the angle gamma, now look here in this place, this is V infinity, and or the other way, we draw the figure other way. say this is the V infinity, and with respect to this is your V earth, the vector, and V resultant is something like this. So, this is your V r. This angle we have shown by beta, and this whole angle as gamma. Remember, this angle and this angle, they are not same. This angle is equal to this angle, and this angle, this is equal to this angle. Okay. Therefore, gamma and beta, they are not the same. Okay. So, from this place we will have tan beta equal to V e sin gamma divided by V infinity plus V e cos gamma. Where gamma is the angle already we have defined. Gamma is the angle as shown here in this figure. So, this angle is okay. Also look here, this is the phi e angle I have shown here in this place. Phi is the angle between your the horizontal line, which is the RE line parallel to RE, and the VE vector. Okay. So, this is phi e. So, from phi e, if I subtract this angle, so we get this as gamma. So, here we can write here gamma equal to phi e minus L e minus L h plus psi. This is your gamma angle. So, again repeating this, this is your gamma angle from here to here, this whole thing is gamma as shown here in this place. Or if we want to show it outside, so this is your from this place to this place, this is the gamma angle. Beta is already shown, and where is the phi angle? Phi angle is the angle between this line and this line. This is your phi. And this is L e minus L h plus psi. Okay. So, this is now you can get all the things here. So, gamma equal to phi minus L e minus L h plus psi. So, therefore, phi is known to us, and perhaps we have written it phi or phi earth. Let me check. I have indicated here as phi e. So, here also I will write this as phi e. So, this is your phi e. So, phi is known to us, L e, L h and psi, all these are known, and therefore, gamma becomes known. So, gamma is known, and therefore, beta can also be estimated. So, all the angles this way can be estimated. L v we write as the longitude of vehicle, which is nothing but L e plus theta. So, L e plus theta angle between this and this is your L v. So, therefore, L v is L e plus theta. phi vehicle, this is the longitude of vehicle, longitude of vehicle, longitude of vehicle phi, this is phi v, longitude of vehicle is we have written by L v. Here as we have indicated this quantity we have to estimate. Okay, so, L v will be okay, already we have indicated this part L v equal to L e plus theta. Okay, longitude of vehicle already we have indicated, we need phi v. So, phi v is beta, here let us write it, phi v we define as longitude of velocity vector of vehicle, longitude of velocity vector of vehicle. Okay, longitude of velocity vector of vehicle, and how much this will be phi v. Now, you can see here this is the velocity vector of the vehicle. This is the velocity vector of the vehicle. V infinity is the excess hyperbolic velocity. V r is the longitude of V r is the velocity vector of the vehicle. So, we will have to write it on the next page maybe. Longitude of velocity vector of vehicle, longitude of velocity vector of vehicle. That means, we are measuring this from the vernal equinox. This is gamma, okay. This is the horizontal line, and vehicle velocity, say this is your V infinity and this is V r. So, V r is your vehicle velocity, vehicle velocity. This angle is beta, this angle is already we have written L e minus L h plus psi, okay. And then other angle we have indicated as this is with respect to the horizontal, and then from here this is your the vehicle, this is your gamma direction, vernal equinox direction we show here like this. Figure is little complicated, but if we do it patiently we can do it. This we have shown as L earth, and this angle we have shown as theta. So, now we can write that angle. So, longitude of this will be L e plus theta with respect to this line we will write the longitude. Okay. So, with respect to this how much this is going to make the angle. Okay. So, we have here so this is a vector and V is a vector here. Okay. So, let us look here in this problem. We first write this as L e minus L h plus psi. This is the angle which we have shown here. V infinity that makes this angle. V infinity makes L e minus L h plus psi. This is the angle that it makes with the horizontal. I will clear it up and write here properly. This angle we have written as L E minus L H plus psi. So, with the horizontal, this is making L E minus L H plus psi, the V r will be making angle L E minus L H plus psi plus beta. Okay. So, with the horizontal, then it makes angle L E minus L H plus psi plus beta. This is with respect to the horizontal with this line. So, with this, then how much angle this it will make? This is the question. So, phi v, we add theta to this. So, theta plus beta L E minus L H plus psi, this gives us this longitude of the vehicle velocity. As we have written here, this is phi v. So, all the angles we have to write here properly to work it out. Okay, so, thus what we are doing here, that once we are writing here phi v equal to theta plus beta L E minus L H plus psi. So, this angle we have added, which is L E minus L H, this angle plus beta we have added plus theta we have added. So, with respect to this line, where this V r, how much angle this is making. Okay, so, if we draw it like this, so this is the angle here we are writing as phi v. So, we should not rather write this as the longitude, that the angle of the velocity vector of vehicle with respect to the radius vector, we should write it this way. The longitude is always measured with respect to the vernal equinox. Okay, so, that won't be a correct term. So, I will change this to phi v, the angle of velocity vector of vehicle, which is V r with respect to the radius vector of the vehicle from sun to the vehicle. So, this is again with respect to the sun, Why this is important, this phi v? Because this appears like a something like if you remember in your description of the earth, here the velocity vector v is given, okay. And if this angle is we are writing as phi v. So, flight path angle immediately we can make out from this place, which will be phi v minus pi by 2, okay, equal to phi. This way we can write, okay. And therefore, once these angles are known, so we will be able to calculate all the heliocentric parameters of the vehicle. Okay. So, this nomenclature I have changed, so that we do not confuse with the actual longitude which is measured with respect to the vernal equinox. And thus, V r is known and r is also known along with the corresponding angles, along with angles. And once this is known, so you know in the orbit determination problem, we can know the orbit with respect to the sun. So, using this, we can determine all the orbital parameters of the vehicle with respect to the sun, that is in heliocentric orbit. So, heliocentric orbit parameters we will be able to determine from this place. What those are? Those are A prime, E prime, capital omega prime, small omega prime, tau prime, time of perigee passage, all these things will be known to us. And this is what we are looking for. Capital omega is not required here, this is not of concern to us, because we are looking into the planar motion. Until unless we refer to the inclination and capital omega, those are out of orbit parameters. So, those are not of interest to us. Only what are the interest to us are these 4 parameters: A prime, E prime, small omega prime, and this is tau prime. So, this is longitude of, this is called as the perihelion. This is the eccentricity as usual. Why perihelion? It is coming from the heliocentric, okay, because it is about the sun, and this is semi major axis. Also, we should note that rho by rho 0 is the radius of the parking orbit, as we have done last time. So, this is your parking orbit rho 0, and outside this we have a sphere of influence whose radius we have written as rho. So, this is much greater than 1, and r by rho, this will also be much greater than 1. So, as compared to the sphere of influence, the distance of the vehicle from the sun, this is very large, and therefore, theta this becomes a small angle, as shown in the previous figure, a small angle of the order of magnitude of 1 degree or 2 degree in most cases. While the direction of V infinity is within a few degree of the planetocentric centric radius vector. What is the planetocentric radius vector? This is rho. So, with rho the V infinity is making only few degrees of angle. So, ideally it should happen that once the launch is done, and if this is the velocity of the earth. So, your after the launch V infinity should come in the same direction ideally, but this will not be the situation as shown in the previous figure. Okay. If this is not the situation, then we have to take into account all the angles and work out. And a small angular or the velocity estimation error here in this place, it results in thousands of kilometers, like the 75,000, like that error while it reaches the Mars. Okay, so, it is a very sensitive. Okay, so, part of this the sensitivity analysis is also there, but we are not going into all those things. Already the course has stressed a lot. So, we want to keep it short. Okay. While we do simulation, so all these things will be obvious in the say if we have already coded and in the computer, then by giving a small error you can check that how much error it is creating. So, we stop here and we will continue in the next lecture. Thank you.